Welcome to the Learning Assistant app YouTube channel. Have you ever wondered how we can be so certain that a pinch of sugar, a drop of oil, or a fragment of wood is truly organic? We're told these things are built from carbon and hydrogen, but looking at a plain white powder or a clear liquid, those elements are invisible to the naked eye. To find them, we have to force them out into the open, using a bit of chemical persuasion.
Let's visualize the setup. We start with a hard glass test tube. Inside, we mix our mystery organic compound with a generous amount of dry copper-2 oxide. That's the black powder you see here. We're going to heat this mixture intensely. Now, why copper oxide? Think of it as an oxygen delivery service. Organic molecules are stubborn, but when heated with copper oxide, they undergo a transformation. The carbon and hydrogen atoms are essentially stripped away and oxidized.
As we apply the flame, notice what happens inside the tube. Let's zoom in on the molecular level. The carbon atoms from our compound are grabbing oxygen from the copper oxide to become carbon dioxide gas. Simultaneously, the hydrogen atoms are seizing oxygen to become water vapor. But a clear gas and invisible vapor don't tell us much on their own. We need detectors. Let's look at the delivery tube leading away from our reaction. First, the gases pass over a small amount of white powdery substance. This is anhydrous copper sulfate. Watch closely as the vapor touches it. The white powder begins to glow with a brilliant blue hue. This color change is our aha moment for hydrogen. The water produced in the reaction hydrates the copper sulfate, turning it into its blue pentahydrate form. If you see blue, you found hydrogen.
But what about the carbon? Let's follow the remaining gas as it bubbles into this second container filled with a clear liquid called lime water, or calcium hydroxide. Initially, it looks just like plain water. But as the carbon dioxide enters, notice how the liquid turns cloudy and milky. This happens because the carbon dioxide reacts with the lime water to form tiny, insoluble particles of calcium carbonate. This distinct milkiness is the unmistakable signature of carbon.
So, by using copper oxide as a key, we unlock the chemical secrets hidden within the compound. The white powder turning blue proves hydrogen was there. The clear water turning milky proves carbon was there. It's a simple, elegant dance of atoms that reveals the very essence of organic matter.
We hope this visualization helped you master the detection of carbon and hydrogen. To truly cement this knowledge, we invite you to download the Learning Assistant app. You can practice interactive tests, access detailed notes, and set up periodic revisions to ensure these concepts stay fresh in your mind. Thank you for watching, and we'll see you in the next deep dive.